Hello grade 10s and welcome to part 2 of the videos on mixtures. In this video we will look at two different types of mixtures. Specifically we will look at homogeneous mixtures and at heterogeneous mixtures. Let's start off by defining an homogeneous mixture and looking at examples of this type of mixture. We say that an homogeneous mixture is a mixture of uniform composition and in which all components are in the same phase. So as an example, I have sugar water. So we have sugar that has been dissolved in water. So what are the components of this mixture? Well, they are sugar molecules and water molecules. Now, since the sugar molecules have been dissolved, or the sugar has been dissolved in the water, it is not possible for us to distinguish between the sugar and the water. Of course, this is when the water is not oversaturated with sugar, so we can't see any solid crystals at the bottom. We therefore say that the mixture is uniform, meaning that no matter where you look at this mixture, the arrangement of the sugar and water molecules are the same throughout. Also, we can say that the components are in the same phase. The sugar is dissolved in solution and the water, of course, is a liquid, so we can't distinguish between the two substances. The sugar is no longer a solid. Our second example of an homogeneous mixture is air, and here I'm specifically referring to the air that we breathe in on a daily basis. Now, a lot of learners think that air is just pure oxygen, but if you know about air pollution, then you already know that there are different substances in the air, substances that aren't always good for our bodies, but also we know that the atmosphere around us does not only contain oxygen. It also contains molecules, diatomic molecules, such as nitrogen gas. Of course, we do have oxygen. There is argon in the air around us. There's even water vapor. Now, you can't see water vapor because water vapor is water in the gaseous phase. And of course, there are a whole lot of other molecules in the air around us. But since air is made up of so many different molecules or different substances, and you can't distinguish between these different substances, we say that air is an homogeneous mixture. Another example of an homogeneous mixture is salt water. Now here I'm referring to salt water in which the salt crystals have dissolved completely in the water. If you look at the image displayed to your screen, you can see it's very easy to distinguish between the salt crystals and the water itself. So at the moment, this is not an homogeneous mixture because the salt is still solid and we can distinguish between the salt and the water. But if we give that salt enough time to dissolve, or we can even say dissociate in the water, then we're going to have a clear solution. In that clear solution, we're going to have, of course, the water. We're going to have sodium ions, that is Na plus ions, and we're going to have chlorine ions. We say that the salt, the table salt, sodium chloride, has dissociated, which means it has broken apart into its different ions. And since we can't distinguish between these ions and the water, we say that salt water is an homogeneous mixture. Our last example of an homogeneous mixture is Oros. Now, in order to mix your Oros so that you can drink it and so that it's not too sweet, we will take the Oros concentrate and pour it into water. You may remember right at the beginning in the previous video, I mentioned that in mixtures, or when we create a mixture, we can mix the components in any ratio. So if you would like really sweet drink, you will take a large amount of the Oros concentrate and put it into the water. But if you don't like it too sweet, then you will use less of the concentrate. But we say that this is an homogeneous mixture because once the water and the Oros has been mixed, it's difficult to distinguish between the two. It looks like we have one solution that is now orange, and that is why this is an homogeneous mixture. Let's now define and look at a few examples of a heterogeneous mixture. We say that heterogeneous mixtures or a heterogeneous mixture is a mixture of non-uniform composition and of which the components can be easily identified. To make better sense of this, we're going to start off by comparing an homogeneous mixture to a heterogeneous mixture. On the left-hand side, we have an homogeneous mixture. The example is black coffee. To create this mixture, we take coffee granules, this is instant coffee, and we place it into warm water. And when we do so, we know that the coffee will dissolve in the water to give us a solution, where we can no longer distinguish between the coffee and the water. You can see on the right hand side in this image the molecules, and it is very clear that we have a uniform mixture, because if we draw a whole lot of blocks or squares of somewhat equal areas, you can see that there's more or less the same number of green and purple dots in each of these blocks or each of these squares. Now on the right hand side, we have an example of a heterogeneous mixture. Specifically, we are looking at oil that has been mixed with water. Firstly, it is very clear that the different components, which are oil and water, can easily be identified. We can clearly see that over here we have the oil and over here we have the water, right? So it's very easy to identify the different components, and that is how we know that this is a heterogeneous mixture. But also, if you look at the diagram on the left hand side, you can see that it is very easy to identify between the different parts. We have at the bottom all of the water molecules, and if we give this enough time, then we know that all of the oil particles, or all the oil molecules, are going to float towards the top of the water, making this an heterogeneous mixture. We are now going to take a look at a few more examples of heterogeneous mixtures, starting off with the salad. When we take a look at the salad, we can easily identify the different components. Specifically, we have some lettuce. Over here, we have some onion. There's a bit of tomato in the salad. And if you look very carefully over here, you can see a bit of feta cheese. Since we can easily identify the different components of the salad, we say that this is an example of a heterogeneous mixture. Then displayed to the bottom of your screen, you can see an example of cool drink. A lot of learners tend to think that cool drink is an example of an homogeneous mixture, but this is not true. What makes cool drink special when compared to juice or just still water is not only the taste, but the fact that it contains bubbles. Now, many people tend to think that these bubbles are acid, but this is actually not acid. These are gas bubbles, and these gas bubbles are carbon dioxide gas that has been pushed or forced into the aqueous solution. Since we can clearly see the carbon dioxide gas bubbles and identify it as being a separate component of this mixture, we say that cool drink is an example of a heterogeneous mixture. If we could remove all of the gas bubbles, and in this picture also remove the ice, then we would say that this is a homogeneous mixture. But because of the gas bubbles, and in this diagram because of the ice as well, this is an example of a heterogeneous mixture. Grade 10s, this brings us to the end of this video. In the next video, we will take a look at pure substances. Specifically, we will identify or distinguish between elements and compounds. I hope to see you there.